What is a force? How are they produced? Why are forces considered a vector quantity? In this video, you will learn the foundational concepts surrounding forces. But before we proceed, let us first define a rigid body. Rigid body is a body that remains undeformed when acted upon by external forces. This is because its particles are fixed in position relative to each other, thus considered to be a definite amount of matter. Rigid bodies are often associated with a solid matter, just like in the steel structure shown in the figure. However, it is important to remember that actual solid bodies are never rigid, however minimal the deformation or relative displacement may be. The relative displacement is describing the displacement between the particles of a rigid body. The evaluation of these deformations form part in the study of the strength of materials. Let us now proceed with the discussion of forces. A force is produced through the action of one body to another, which will tend to change the state of motion of the body acted on. Therefore, a force will only exist if there is a body that would exert it. In layman's term, a force is referred to as a push or pull. The external effects of a force to a rigid body depend on, first, the magnitude of the force. The magnitude is the size or extent of the force. It answers the question, how strong or how weak is the force? Second, the position or location of the line of action of the force in the body. A force that has a line of action that does not pass through the target body will not produce an external effect on the body intended to be acted on. And the third one, the sense or direction of the force along its line of action. These three parameters comprises the characteristics of a force. There are two basic classifications of forces. The first one is surface forces or forces of contact. Second is body forces or forces at a distance. A surface force may be considered a concentrated force when the area over which the force is distributed is relatively smaller as compared to the surface of the body being acted on, that it may be regarded as a point. In the figure, the area over which the man's weight is distributed is relatively smaller compared with the surface of the earth. Thus, we can consider his weight as a concentrated force. The principle of transmissibility. The external effect of a force on a rigid body is the same for all points of application along its line of action. From the figure, the box on the left is being pushed by a force going to the right. The middle box now is being pushed by the same force of equal magnitude, and its point of application is at the center of the box. The box on the right, however, is being pulled by a force of equal magnitude going to the right on the right part of the box. The external effect of these three forces on the box is the same as long as it passes through the same line of action. It should be noted, however, that the external effects only remain unchanged. The internal effect of the force varies. That is, when applied on different points along the line of action, the internal effects are not the same. On the left box, the internal effect is concentrated on the left part of the box. The middle box, however, has an internal effect concentrated at the center of the box. And the last box on the right has an internal effect concentrated on the right part of it. Using the principle of transmissibility, we no longer have to determine whether a force is a push or a pull. Consider a box with total downward force, in this case the weight, acting perpendicular on the surface of the floor. This downward force will be countered by a force called the normal force, from the word normal meaning perpendicular. It also acts perpendicular to the surface of contact with equal magnitude but of opposite sense with the weight. This is an example of force system in equilibrium state. If a force system or a combination of forces applied to a body does not produce an external force, the forces are in equilibrium or in a balanced state. And the body is also in equilibrium. Therefore, there is no change in motion of the object being acted upon. If the force system is unbalanced, it will change the object's state of motion. This unbalanced force system will produce a resultant. The discussion of resultant will be covered in another video with the link in the description below. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.